Alright, we're back to our workbench. We're going to get started with a similar process, but for laminar flow this time. Alright, right-clicking on geometry, new design model. And similar to before, we're going to start sketching. Sketch a circle around the origin. Add some dimensions. In this case, a diameter of 1 meter. Draw some lines along the horizontal axis. Now we're just adding our dimensions. I'm going to change these to 25 meters each. Again, we're going to insert some lines perpendicular to the edges here. Add some dimensions to these. Change them to 25 meters. Because again, we're going for a rectangle that's 50 by 50 meters. Now we can input our rectangle. I'm just going to go in here and clean up some lines really quick. Bring this one back. And this one too. Just delete some of these dimensions and extra lines. And now we're going to go to concepts, sketch from surface, and apply. And hit generate, and we've created our sketch plane. All's looking good, so we're going to move on to mesh. Click on mesh. Insert, method, select the face, and then hit apply. I'm going to change this to triangles. Hit generate. And click on mesh, right click, insert, sizing. We're going to pick our edge select tool. Click on the edge of the circle. Change the number of divisions. Change that to 250. Select no for capture curvature and behavior to hard. And hit generate. And again, we're going to right click on mesh. This is looking pretty good so far. Right click on mesh, insert, and then inflation. First select the face, hit apply, and then select the edge of our circle, hit apply. Change this to first layer thickness, and define it by first layer height at 1, and our maximum layers at 15. And hit generate. It's looking pretty good for our purposes. Now we're just going to name our edges. The left one being the velocity inlet. On the right we have our pressure outlet. Top and bottom edges we're going to label as symmetry. And the edge of our circle we're going to name wall. I'm just going to double check everything, making sure it's appropriately labeled. Just update this really quick and then we can move on to our setup. Make sure we select double precision. We can hit start. Double check everything in general. Looks good. And then over here we're going to select laminar. Then we got materials, fluid, air. We're going to modify our density to 1 and our viscosity to 0.1. We're just going to double check that our fluid is air, just to make sure. We can go to our boundary conditions and select inlet, select velocity inlet, and change our velocity to 15 meters per second. We're going to make sure we compute from our inlet. And all our values are updated correctly. This looks good. Check this. Check our residuals really quick. And we're going to go to initialize. Change the number of iterations to 25. And apply. And initialize. Change this to 1,000. And then calculate. And the calculation is complete. Moving over to results. For the XY plot. And we're going to start to compute our pressure coefficient from the surface of the wall. You can see the graph here. This looks good. And we're going to make sure we write this to file. We're going to generate another plot, this time velocity, again from the wall. You can see there's no variation in velocity, which is what we want to see. Write this one in the file as well. We can go to our report definitions and insert a force report. Select drag, zone as the wall, hit compute, and it should write to the console. You can see our drag coefficient right there. And we can copy and paste our data. We just got from Ansys. We're going to put this into Excel, a similar process as last time. Select data series, select data, and we're going to add a series. Laminar, so we're going to make sure we select the data correctly. Select our X values. And select our Y values. Now we can see we have our laminar and viscid overlaid against one another to compare. And we're going to do the same thing with velocity. Select the file, open it in Notepad, and then select the data. Alright, that's what we want to see. Then we can go over to results. We're going to insert a contour. The location of symmetry 2. Change number of contours to 110. And here we have our pressure contour. You can zoom in and see the pressure variation as it passes over the cylinder. You can see our high pressure region and low pressure region. We're going to apply another contour for velocity. You can see the variation here. And then we're going to insert a streamline. We'll start from velocity inlet. And then change our number of points to 1000. Here we get a pretty good depiction of our streamlines. We have a sizable wake region. And that's going to be all for our laminar flow.